Okay, so continuing in our discussion of the rationale for the EI+UI strategy, let's just remind ourselves of what the EI+UI strategy does. So the first step is we say, take each of the existential quantifiers and existentially instantiate them. And you do that once. Remember, EI is always to a new free variable. And then you take each universal quantifier and you apply UI to it. And remember that UI can be to any term you want. And so you can UI, any term you like. And so in particular, you apply, you take each universal quantifier and then instantiate it to each variable you get from EI. And also you instantiate to any of the names that show up in the derivation. And then with that stuff, you're getting, in the end, quantifier-free formulas from that. And then you extract the contradiction. And the question we were asking is, then, this relies on the idea that you start off with a set of inconsistent sentences that cannot all be true, that have quantifiers in them. And then you apply the EI+UI method, and in doing so, you get quantifier-free sentences. And then the idea is that those quantifier-free sentences will also be inconsistent. Now, there's no guarantee that in general, using EI and UI in any old way will get you to inconsistent quantifier-free sentences. To illustrate that briefly, let's look at derivation 313. So we have here, we're showing for all x fx, so we assume ID, and then we'll qn right away. So here we have an existential quantifier, so our first thing to is we do EI. Now if we look at the premises, we have a universal for all x if and only if gx or hx. We have existential x gx, and then for all x if fx, then for all x hx. So we want to instantiate the second premise, that existential quantifier. So that's all the existential quantifiers in this derivation. So we're done with the first stage of the EI+UI method. Now, let's start with the UI part of the method. So we have a universal quantifier in premise 3. So let's say we instantiate that universal quantifier to just to, let's say, to I. And let's say also we look at the universal quantifier in the third premise and instantiate it to I. Okay, so we might look around and see, well, what can we do? And really the only thing we can do is we can do BP with lines 3 and 5. Since we have not fi, the left side of the biconditional is false. And that means, and what we infer to on line 7 is that the right side of the biconditional is false. Okay, now, so we have a bunch of quantifier-free sentences, 3, 4, 5, 6, and 5, sorry, not 6, it's 7. 6 has a quantifier in it, which introduces a different wrinkle. We'll not worry about that. If we look at 3, 4, 5, and 7, though, are those sentences inconsistent? No. It's possible for all of them to be true. In fact, it's even possible for all of them plus 6 to be true. So we did some EI and some UI. We started off with a bunch of quantified sentences. The first premise, the second premise, the third premise, and the indirect assumption. And we did some EI and UI. But did we get to a set of quantifier-free of sentences that are 1 quantifier-free and 2 inconsistent? No. We have these quantifier-free sentences, but they're consistent. All of those 4 sentences could all be true at the same time. So it's not in general guarantee that if you do some EI and some UI, you get to quantifier-free inconsistent sentences. No guarantee of that. So why does it work? Why does the EI+UI method work? It does get you to quantifier-free inconsistent sentences. Why? That's the question. So the EI step, well, let's think about EI. So when you do EI, you go from an existential generalization, like sum x, fx, and gx, to an instance of the general claim. So let's say fo and go, and it's an instance of the general claim because now you're talking about a particular thing, whatever O refers to. And you're saying that it's f and g, whereas before, in the previous claim, it doesn't say anything about which particular thing is f and g. Okay, fine. So it's a valid rule in the context of our system, and that means that if the generalization is true, the instance is true. If the premise is true, the conclusion is true, the premise is the generalization, the instance is the conclusion. But it's also the case that if the conclusion is true, then the premise is true. If the instance is true, if fo and g is true, then so is the premise, the generalization. So that means that when we're done with the EI step, of the sort of the EI part of the first stage, we get to some quantifier-free sentences that are like this. If they're true, then so are the existentials in the premise and assumption. And if we jump back to our derivation, we see yes, right? Not fi, if not fi is true, then some x not fx is true. And if gj is true, then some x gx is true. And that's the end of that, the EI part. And we know, yeah, okay, we're done with the EI part, and what we have are two quantifier-free sentences, such that if they're true, then so are all of the existential sentences. Now, what about the UI step? Well, suppose that fi, fj, and fk are true. Does it follow that for all x, fx is true? No. There may be unnamed objects that aren't f, or even just objects that are named by things besides I, j, and k. If everything that there is in the world is named by either I, j, or k, then if there's something that's not named by I, or j, or k, then fx, for all x, fx might be false, even though fi, fj, and fk are true, right? So for example, if Igor is a frog, and John is a frog, and Carl is a frog, does it follow that everything is a frog? Not at all, because there may be all sorts of other things besides Igor, John, and Carl. But suppose that all the objects are named. Suppose that, in fact, there are only three things that they're named by I, j, and k. Then, if fi, fj, and fk are true, in fact, for all x, fx is true. So if we have a bunch of instances of a universal generalization, the universal generalization is for all x, fx, and then we have particular instances. So this is f, or that's f, or the other thing's f. And we have a bunch of instances. Their truth does not, in general, guarantee the truth of the universal generalization. But if in fact we've named everything, and we have an instance for with each of our names, then actually, if all of the instances are true, then the universal will be true, because whichever thing you pick, it's Igor or John or Carl, we say, yes, we have a particular instance, say John, and we look and say, oh yes, we're saying that John is a frog. So in fact, if you have some instances and you know that everything is named by the names or variables in those instances, then the universal will be true as well. Now let's think about what that means in the EI strategy. That what we're basically trying to do when we universally instantiate the universal quantifiers to the variables from EI and the names in the derivation is to get to this group of quantifier sentences that are like this. If all the objects are named and the quantifier-free sentences that we get from UI are true, then the universals will be true. So if let's just have this one piece of terminology. We'll say that what's a small world? A small world is one in which all the objects are named. So then we can say, once we're done with both EI and UI, we instantiate each of the existential quantifiers once to a new variable, and then we instantiate each of the universal quantifiers to each of those variables and any names. Then we're going to get a group of quantifier-free sentences, and they're going to be like this. If they're all true in a small world, then the universals and the existentials that we started off with are also true in that small world. We saw why if what we get from EI is true, then the existentials that we started with are true. And we also saw that if what we get from UI is true and everything is named, we're in a small world, then the universals are true. So we put those two together and say if we apply EI and UI, then what we're going to get are a group of sentences that on the one hand are quantifier free, and on the other hand, if they're all true in a small world, a world where everything is named, then the general sentences, the quantified sentences that we started with, they're also all true. Now we can rephrase that to say, if we have a small world, and the universals, it's not the case that all of the universals and existentials are true in the small world, then at least some of these at least one of the quantifier-free sentences are also not all true in the small world. So first we said, if all the quantifier-free sentences are true in the small world, then also the quantifier sentences are all true in the world. But that we can also say, if at least one of the quantified sentences is not true, then at least one of the unquantified sentences is also not true. same thing. It's just the contraposition, right? If P, then Q. If not Q, then not P. So this is what we get to. What the EI+UI method is telling us, what the EI+UI method says is if we start off with a group of sentences that aren't all true, and then we do the EI and UI, we also know that, at least according to the method, then that new group of quantifier-free sentences, also at least one of them is false. Okay. Now let's remember that if we say that, let's come at a different point. We have a valid argument. That means that no matter what, if the premises are true, so is the conclusion, which means that it's not possible for the premises and the negation of the conclusion to all be true. Okay. So what this means is that if we're in a small world and it's a small world in which it's not possible for the premises and the indirect assumption to be true, they cannot all be true, then also it's not possible for all the quantifier-free sentences to be true in that small world. And that means, in fact, it turns out that it's not even possible, that it's never possible for all the quantifier-free sentences to be true. If they could be true at all, they could be true in a small world. They can't be true in the small world. They can't be true at all. In other words, they're inconsistent. So what we're seeing here is this. Remember, the question was, we start off with some inconsistent sentences, the premises and the indirect assumption, and they have quantifiers in them. We apply the EI+UI method, and the idea is we get to quantifier-free sentences, and that group of quantifier-free sentences is also inconsistent. Okay, why is that? Fundamentally, it's because if the quantifier-free sentences that are generated by EI+UI are all true, then so are the initial sentences we started with. And that we need to qualify that a little bit because of the small world idea. But basically the idea is if the quantifier-free sentences that you get from EI+UI are true, then so are the quantified sentences. But the quantified sentences can't be true, they're inconsistent, and therefore the quantifier-free sentences also cannot be consistent. They're inconsistent. They cannot all be true. And that's what we wanted to understand. So how do we know that they're inconsistent? Because of the EI+UI method. So why is this important? So this is important just for you to understand how the system is working, but it also has strategic implications. In particular, it means to the extent that you can, you want to separate these two stages. First, there's the EI+UI stage, and then there's the chapter 1 and 2 stage with the quantifier-free sentences. So to the extent that you can pull those apart and keep them apart in your head, as you're proceeding, you want to say, am I in the EI+UI stage, or am I in the chapter 1 and 2 stage? Then in the propositional quantifier-free stage. Now, as we'll see in more difficult derivations, you won't be able to keep those two stages perfectly separate from one another. They will overlap, but it still helps to have that idea that they're those two different stages. Then the other thing is, though, what this means is that if you're having trouble completing the derivation, one possible reason is you haven't followed the EI+UI stage properly. You're trying to do all these sentential manipulations with stuff that don't have quantifiers in them. It may be that the reason why you're not getting a contradiction out of the stuff that doesn't have quantifiers in them is because you haven't done enough EI and UI, and in particular, probably you won't have done enough UI. So that's what you want to look out for. Have I done UI to all of the free variables and to all of the names if there are any? If you haven't, then the quantifier-free sentences may not be inconsistent, and so the reason you're not getting a contradiction is because you don't have you don't have a group of inconsistent quantifier-free sentences. So try to keep the stages separate. You won't always be able to do that in more difficult derivations. And then make sure that you're doing enough EI. That's easier to do. You just instantiate each of the existential quantifiers, but then really look out, have I done enough universal instantiation? Have I instantiated each of my universal quantifiers to each of the different variables? In some cases you don't need to, but if you're not getting a contradiction, you probably haven't done enough UI. So that's the strategic upshot. Next video will be, and I'll be illustrating this in some of the derivations. The next content video or sort of lecture content video will be on a symbolization issue, relative and restrictive clauses.